Hello everyone, happy to see you here. Welcome back to my channel Hi Mathematics. Today we have very interesting, relaxing and tricky algebra question. We need to find our x and y, we need to find our integer solution, and we know that x squared minus y squared equal to 12. If you have your answer, your assumption, you can also write your assumption down into the comment section and then we will check our answers. Okay, so how can we solve this question? First of all, we need to mention that we have a difference of squares. We have x squared minus y squared, and from school you need to know a really important formula. I'm going to write it in terms of a and b. So our formula looks like that: a squared minus b squared, a squared minus b squared, and in terms of our school knowledge, in terms of factoring, this is equal to a plus b times a minus b, a minus b. And let's apply this formula right here. We will have absolutely the same thing, but in terms of x and y. Let's do this right now. As a result, from the beginning, we're going to have x plus y times x minus y equal to 12. Right now, the second step, what we're gonna do, we're gonna express this 12 in a different way. So this 12 we're gonna express as a product, because if you look closely, according to a basic like knowledge, we have a product of two values. We have the first parenthesis and the second parenthesis. So let's express this 12 as a product of two numbers. In our case, in terms of two values. So the first way, how can we express it? This is like the easiest one, I guess. We have 12 times 1. 12 times 1. The second way, of course, we can write it in a reverse way, 1 times 12. The third way, what we're going to write? We're going to write 6 times 2. The fourth, we're going to write 2 times 6. 2 times 6, and we have 4 times 3, I hope you get it, and 3 times 4. And one really important moment, because a lot of students forget about it, if you look closely, x plus y and x minus y, which one is greater? So I'm going to write it on the right here on the, or let's write it right here, okay? So we have x plus y, and we have x minus y on the left side, x minus y. Which one is greater? I hope you understand it, that x plus y is greater than x minus y, because when we add y to both sides, let's add it. So let's add y to both sides. As a result, we're going to cancel it from the right side. So we have x plus, not y, but 2y, because we add in y, and right here we're going to cancel it because we have minus y plus y, so greater than x. So I really hope you see that x right here, but on the left side we add in 2y. So our left side, this one, x plus y, is greater than our right side. And that's why we need only expression, we really need combination where left side is greater than the right one, okay? So as a result, what we're gonna do, we really need this one expression, this one combination. We don't need this one because 1 is less than 12. We need this one. We don't need 2 times 6. We need this one. We don't need 3 times 4. So I really hope you understand. Extremely important moment, because then you're gonna solve 3 more system of equations, and then you spend more time to this. And of course, if you know it, you can easily use this way. You can easily check only these three combinations. So let's start, for example, with the first one, 12 and 1. So for this combination, x plus y equal to 12, x minus y equal to 1. So our first expression, yeah. So as a result, we have x plus y equal to 12, and x minus y equal to 1. There is a great way how can you solve this type of system of equation, because we can easily add both equations, and then we're going to cancel this y. So from here we're going to have 2x equal to 13, and if you're talking about x equal to 13 over 2. If x equal to 13 over 2, yeah, from here x equal to 13 over 2, but we need to find our y. Let's plug in this x, for example, in the second equation. As a result, what we get from here, from the second equation, we're gonna have 13 over 2 minus y equal to 1. Let's multiply this equation by 2. So let's multiply it by 2. As a result, what do we have? We have 13. We have 13 minus 2y equal to 2. From here we have minus 2y equal to minus 11, and as a result, our y equal to 11 over 2. And a really important moment, I want to underline this moment real quick, because we need, from the beginning, we need to find our integer solution x and y. And if you look closely, x is not integer, y is not integer solution. So we reject this this pair of solution. But if, for example, if you need to solve this question not with the definition that x and y need to be integer, then you can easily use this route, because this is a correct route for our question. But in our case, we solve only for integers, so we reject this part. Okay, so we reject it. Let's go to the next one, 6 and 2. Okay, let's do this. So as a result, x plus y equal to 6, and x minus y equal to 2. The same thing, let's add both equations. So as a result, what do we have? We have 2x equal to 8, and from here x equal to 4. So it is great for us. This is our integer, but let's find our y real quick. Where can we find our y? Let's plug in this into the second equation. So from here, x minus y equal to 2, but our x equal to 4. So we have 4 minus y equal to 2. And as a result, from here, our y is equal to 2. And as a result, we have one pair. We're going to check this pair a little bit later, but we have integer answer, x4 and y equal to 2. It's not the case that we had in the beginning with the non-integer pair, so we don't need to reject this one. We're going to check it a little bit later. And the last one, 4 and 3. This is our last case, so this is our 4 and 3. We're going to have x plus y equal to 4 and x minus y equal to 3. Let's add it with the same principle, with the same algorithm. What do we have from here? We're going to have 2x equal to 7. And of course, on this moment, you can easily see that x equal to 7/2. And if you don't need it, you can easily leave this third case, because we don't have right here integers. But maybe if you maybe sometimes you need to solve this question completely with not this restriction when we need to find only integers. So that's why we're gonna solve it until the end. So let's find our y. So from the second equation, x minus y equal to 3 and x equal to 7/2. So we have 7/2 minus y equal to 3. Let's multiply it by 2. Let's multiply our equation by 2. And as a result, we have 7 minus 2y equal to 6. So we have minus 2y minus from here. This is our next step. So minus 2y equal to 6 minus 7 equal to minus 1. And from here, our y is equal to 1/2. Okay, so let's write our final answer. We solved this question. Yeah, we checked all these combinations. So first of all, if you need to solve this question completely without any restrictions about like integers, not integers, you can easily use this pair. So 13/2, 11/2. So our x and y equal to 13/2, 11/2. Second pair, this one, 7/2, 1/2. 7/2, 1/2. If you need to solve this question completely, these both pairs, it's not integer. But if you want to solve this question in terms of integer, we found one really important pair, x equal to 4 and y equal to 2. So our x and y, this is our answer to this question, equal to 4 and y equal to 2. Let's check it real quick. Let's check this pair, x and y equal to, this is our integer, and this is our integer pair, so integer. So this is the pair that we exactly need to our question. So x equal to 4 and y equal to 2. So from the beginning, our question looks like that: x square minus y square equal to 12. So from here, our x equal to 4. So we have 4 square minus y square minus 2 square equal to 12, and this works perfectly because we have 16 minus 4 equal to 12, which is absolutely correct. So if you need to solve this question completely, you need all of these pairs. If you need to solve this question in terms of only integers, so this is our answer to this question. So 4 and 2, this is our non-integer solution. So we had it in the first case, we have two non-integer pair, x and y, and in the third case we had x and y, two non-integers pair. So I really hope you understand it. This is not the hard question, I'm not gonna lie. This is like a basic relaxing algebra question, so I really hope you you understand my explanation. If you still have any question, write a question in the comments below. Let's discuss a little bit about this type of question. Maybe you have a faster method. How can you do this? This also really great to exchange information, and I really hope you understand my explanation. And thank you everyone for your time. Wish you all the best in your life. Take care of yourself. And I'm really grateful that I have this type of audience. I had that like 100k audience. I'm really impressed. I'm really grateful that we are watching math questions. And it really inspires me a lot to make new content every day. So I really want to say thank you everyone for supporting my channel, for watching my questions. We have like more than 500 different Olympiad math questions. So it's really great, I guess, that we had this type of community. I'm really grateful, and I want to say thank you everyone for watching this type of questions. So wish you all the best in life. Take care of yourself. Have a great day. Also write your response, write your notes, write your assumption down into the comment section. It will be really interesting to read about it. And wish you all the best in life. Take care of yourself. See you in the next videos, and have a great day.